Good morning, everyone. I had typed my greetings in the chat box, but some of you might have come in afterwards, so allow me to greet everybody again. Good morning. My name is Cynthia Bell. As Eric said, I work for the Literacy Assistance Center, but I'm also a member in the Adult Numeracy Network. That was the association that he mentioned in my introduction as well. And I put this session together for a group. As we have in New York City, we run a peer learning community. And I put this session together for a group of math instructors. So I'm saying that to give you the heads up that this is meant to be a conversation and engaging. So if your intent was to just come on and let Cynthia talk to you for an hour, I hope that you might switch that because then there will be a lot of dead space. Because those of you who know me know that I am a big fan of wait time, right? So I will give you time to respond. I don't have a lot of slides because the point of this was to try to have a conversation. We will look at some specific strategies and things like that, but I also want to make space for us to have a chance to think about things because the session is called Nurturing Critical Thinking Skills. Now, it's nurturing critical thinking skills in math, but critical thinking is a vital part of just being a human being. So, in this regard, I'm kind of thinking about like using math as my tool to nurture critical thinking. But if you teach any subject, you teach critical thinking. So I hope that this even inspires you, whether you ever teach math or not, to think about different ways and intentionality to nurture your students' curiosity that will help them to start to develop that critical thinking. Creativity and curiosity, in my opinion, is a little bit of a lost art form in education. We need more creativity and more curiosity. I noticed that, and therefore I wonder why. For example, this morning I noticed that my 16-year-old was still home when I woke up instead of at school. And I wondered why she was home, right? Okay, see, we noticed and we know. I became instantly curious. It turns out that it's finals week and she took all her finals. So now she's home early for summer. Yay. Anyway, so we're going to talk about curiosity to mastery. And I hope that you all are going to engage with me. We got three objectives. One, as I said, we're going to share. Sharing is caring. We're going to share specific tasks that can promote learners' critical thinking. We're going to reflect. I'm going to make sure that all of us have time to reflect on being intentional and how you can apply different critical thinking tasks. And of course, as I mentioned, we're going to engage in these tasks. You're actually going to get a chance to participate in some critical thinking yourself. So I hope everybody's got their thinking caps on. And we're going to jump right into it. Here's our warm up, but it's also one of the tasks. This is one of my favorite critical thinking tasks that I give learners at any and all levels because there's a lot of things happening here, but it has a low floor, which means accessibility, and high ceiling. So let's try it out. I'm going to give us plenty of time to think about it. So as you can see, there is a image here. The first thing I would encourage you to do is note everything before you jump in to try to do things with numbers. Notice everything. So our prompt says choose a region. You get to choose whichever region you want. A, B, C, D, E, F, G, whatever region you want. And now take a moment to consider what fraction of the larger rectangle is the area of your chosen region. So this is the part that's going to make your recording really boring, Eric, because I'm going to stop talking and let everybody try to answer this question.
We can I can speed it up.
Okay.
And then here's some of the answers.
We're going to take like a good minute, 2 minutes to really think about this.
So Caesar's chomping at the bit. He's put one of his answers in the chat already.
Trying to break the ice.
I'm gonna give another minute for people to consider. And feel free to select another region if you already have, and come up and see if you can come up with a different way of figuring out the answer for your second region.
Caesar, breaking the ice is a nice segue from the first segment, from the first session.
Oh, yeah. True.
Okay. So we are going to just actually, I'm modeling this task for us, and then we'll break it down from the teacher side. So I would love to hear from someone. You can type your answer in the chat box, or you can unmute yourself. Tell us the chosen region. I care less about your answer and more about what you did to figure out your answer. So somebody, if you want to unmute yourself and tell us your name and your chosen region and your strategy. What was your strategy for coming up with your solution? Ooh, I love all the answers in the chat box.
I can volunteer to explain my answer.
Hi.
Hello. My name is Lauren. I'm a English as second language teacher, so I'm not a math teacher. But I didn't say math person. I said I'm not a math teacher.
Right.
I was like, don't do it, don't do it. Okay. Go ahead.
So I picked, I guess it doesn't really matter if you pick D or E because I believe they're the same.
Ooh.
But I picked this circle. I mean, so I didn't want to have to write down any math, so I tried to do everything in my head. But my reasoning is this rectangle, the whole thing, C, E, F, and D is 1/4 of the total size. And then, for example, D is 1/4 of the size of this part. So then 1/4 divided by 1/4 would be 1/16.
So you said you did 1/4. I'm just trying to annotate. I'm actually modeling as well, right? We're running a number talk. Those of you who took my session last month, we're running a number talk, right? The job of the teacher is just simply to record what they hear the students saying. So you said you did 1/4 divided by 1/4. Can you you said something really interesting. You said, I know, or I think you said, I assume that D and E are the same size. Why'd you make that conjecture?
Because the lines go straight from corner to corner.
Oh, okay.
So,
are you talking about this line right here that I poorly drew?
Yeah.
Okay.
Yes.
Okay.
So they meet in the exact middle of the larger, the rectangle shape. So it would be dividing it equally.
Okay.
I think C and F would also be equal.
Okay.
In size, not in shape, but equal in like the area.
Okay. Meryl dropped in the chat box. She noticed that the colors are the same. So therefore that would imply that they are, I'm only bringing that up because you mentioned you're an ESOL teacher, right? This is why I said there's lots of ways to teach critical thinking. So now we're talking about the colors. We're talking about the shapes. We're noticing that they're called triangles. You didn't know the word, but here's where I would insert the word for you as a vocabulary learner, whether you're a second language learner or a math vocabulary learner. This word would be called our diagonal. The diagonal of this shape goes from one right angle to the opposite right angle, and it's splitting. It's going to bisect our rectangle there. So this is our diagonal. And that diagonal would tell us that both sides of this rectangle are going to be the same. Maybe I would take this opportunity if I was teaching area to talk about why the formula for an area of a triangle is 1/2 times base times height. It is half of a rectangle. So we find the area of a rectangle and we do what? We cut it in half. And what shape did we get? We got a triangle. And that is where the formula for area of a triangle comes from. So I believe you said your answer was 1/16 for D?
Yeah.
Okay. Thank you for sharing that. Would anybody else like to tell us a strategy that they used? Hopefully, if it's a different strategy, because there's actually lots of ways. This is why I love this problem. There are a lot of ways that you can go about figuring out the fraction of your region. Does anybody have a different way that they would like to share?
Yes, I did. I found the region for B.
Mm. B?
And
Mhm.
yes.
Go ahead.
So we can see that on the x-axis, we go from 3 to 4, so that's 1. And on
Ooh,
the
you used the
y-axis,
scale.
we go from 0 to 2, so that's 2. 1 times 2 is 2. And then for the area of the total shape, we have 8 times 4, that is 32.
Okay, keep going.
And then 2 over 32 simplifies to 1/16. So that's why I think B is 1/16 of the total of the whole shape.
Oh, okay. Look at you making use of the coordinate plane and the scale. The few people whose cameras are on, I see a couple of people smiling. This is why I love this problem. I've done this problem with different people at different levels. Some people immediately notice the scale, and others are like, oh, snap, I didn't even see those numbers were there, right? There's lots of like flexibility in critical thinking. Or I've had students who saw the numbers and then asked, am I supposed to use these numbers? And all I say is, what do you think? Would using those numbers be helpful to you? If so, feel free to use them. That's what critical thinkers do. We take all the information that is presented to us and we use it in whatever way is necessary for us to try to figure something out. Anybody else have a different way that they used it? So we got I use my understanding about fractions. We've gotten I use my understanding of area. Anybody else who was like, I didn't really like any of the numbers, so I tried this.
Hi, I just said I'm going to pick H plus G. That's half of the diagram, and that's 50%. That's all I did.
Oh, well, but that's a good place to start. So, okay, I heard you say that you took H plus G and you knew that H and G was half. How did you know that H and G was half?
Well, visually I can see it, but also looking at the scale, let me confirm. Yeah, looks
Okay.
like it.
Okay. So I was actually hoping for someone who went with it looks like, right? So, but I noticed that you said, I stopped there. Is there anything that you could do with the information that you have to try to narrow something down just a little bit more? If you were just dealing with the shapes?
Not really. No,
Okay.
no, without more steps.
Well,
ESL here, ESL.
if we did that, what shape does G look like now?
Okay, looks like a smaller rectangle similar to the total of C, E, F, and D, and the total of A and B.
Correct. Okay, so we're getting there, right? Like we're figuring out things, right? Which would that mean that this region here and this part here also be the same?
Which ones?
The region H right here and what's left of this little section here, would that also be the same as C, D, E, and F and A and B?
As a total, yes.
Okay. All right. So I think if we gave you a little bit more time, I think you could figure some things out here, right? I mean, granted, luckily we only have an
No,
hour together.
I'll pass to the next person.
Oh no, I'm gonna have to leave us there. That's why I said if we had more time. So for let's put our teacher hat on for a second. I love this. I love this activity actually, right? Because I can teach all kinds of things with this one task. And that's actually where we're about to go. Here's my question for you all, if I can pull my notes back up. What math concepts or skills does that task nurture? Right? Like, let's see, like all of the different math you could possibly teach or help people develop, whether it's the concept or a math skill. What math concepts or skills would that task help develop or nurture? You can drop them in the chat if you feel like you've got a really long list. Let's take a moment to think about it. What's all the math that you see?
Well, people are thinking about that as somebody that works on close reading of text. Like part of me was like, why is D bold and C, E, and F not bold? Like, what information is that providing? I was like, I still was like, okay.
You noticed and you wondered. Good for you. That's just a matter of me being able to do the best I can with drawing this image.
Yeah, that's what I figured. But some part of my brain was like, oh, that's some information. It's like,
Got you.
I'm like,
Colors, graph scale, congruent angles. Ooh, Tanya went there. I like it. Congruent. Oh, right. As a matter of fact, I was just tutoring somebody in angle relationships. And so now that is fresh in my hand. I'm like, we got alternate interior angles, right angles, division. I am here for it. Percents, fractions. There's one I haven't seen yet that Caesar did throw out when he was giving his example. Spatial reasoning. I like that one. Yep, spatial. And that's actually key. We're going to talk about that in a second. Area. You mentioned area, right? You threw out formulas at me. You said length times width. Think about what I know to solve it. Good. So you're making connections. There is a reason why I would use this task, and it could be for any one of those things, right? In fact, I reused this task a number of times in one semester, right? Students are like, not this again. And I'm like, yep, because now we're going to talk about the coordinate plane. Or, yep, now we're going to rethink our understanding about fractions. I love that someone threw out percents at me, right? This is 50%. We could also do decimals. We also have multiplication of fractions, right? 1/4 of 1/2 is 1/4 times 1/2, right? If I say I've got half of this rectangle and then I have 1/2 of that 1/2, that's 1/2 times 1/2. So I would even use this to help students develop conceptual understanding about what happens when you multiply fractions versus what happens when you divide fractions. Because a lot of students have a misunderstanding that division always makes things smaller. That's not true all the time. That's a sometimes true statement. If I divide fractions by fractions, that actually makes it bigger. But if I'm trying to find 1/2 of 1/4, that's multiplication. And that got smaller because you took something that was small and then took a piece of that thing that was already small. But that is a conceptual thing that is hard to wrap our mind around when we're just writing numbers on our whiteboard and saying this is 1/2 times 1/4. But if I want students to really understand that, which gets me back to Eric's point about spatial reasoning, I'm going to do this task because this really connects the understanding that a fraction is a space. It takes up shape. It's connecting my spatial reasoning with my understanding of fractions. And this is one reason why fractions is one of the dreaded F words in math, because we disconnect it from things that people already readily know and understand. And then we just really only talk about fractions as pizza pies. I like to talk about fractions in rectangular form.
Yeah,
I'll
Cynthia, I
just
think,
throw out one more thing that I've seen a student do, which I absolutely loved. I saw a student find and figure out they literally used it kind of like as a scale, right? They noticed that they couldn't figure out like the fraction part, but they noticed kind of like Caesar that they're like, this one goes one. It's like it takes up one space here. And then they noticed that it takes up two spaces there. But what they noticed, and they took that and they literally used it all the way across the thing. They're like, that's one B, that's another B. So that's four B's there. And then they're like, well, then that means there's four B's here. And then they counted how many B's there were, and they totaled up that there was, I think it was 16 B's. And then they went with a ratio. They're like, well, if there's 16 B's total and I only had one of them, then that means B is 1 out of 16. And my mind was blown. And I'm like, now we're talking.
Cynthia, I was gonna say, I've seen a pie chart as a opposite to a pie chart. I've seen sort of important data and statistical information presented in this sort of rectangular chart, right? And I've used one with my students, my ESL students once. I'm on different forms of theft in the US, right? And so like wage theft is like the largest block, right? And then like larceny is like the tiniest little block, right? And it was the same thing. Here's this rectangle, right? And then how much space does each one of these types of theft take up? And for some of the students, I felt like it was much easier to understand the relationships in terms of percentages and fractions than on a pie chart, right? Because with a pie chart, it's just kind of like, all right, this one's bigger than this one, but I don't really know how much bigger, right? But if it's a rectangle or a square, I can see, all right, this is 4 times the size of this one, or this is twice the size.
Exactly. And that's connecting again our spatial reasoning to those percents, to those fractions, to those decimals. So for those of us who teach math, but even maybe those of us who teach other subjects where we know we're dealing with people who are learning math, helping them to recognize that that space is connected to that fraction is a really helpful thing to do, because now it's not just 1/16. I don't know what that means. But if I look at this, that person clearly recognized that this was the smallest shape and they did something with it. And they're like, they recognize that this little thing makes up this big thing. That's the definition of a fraction, right? Part of a whole. So we identified math, but more specifically, different concepts and skills. Cynthia, I thought you said we're talking about critical thinking. Well, first of all, we were all doing all of the critical thinking, right? My job as the teacher is to give them the opportunity to do the thinking, to make use of their thinking, to leverage that thinking, and now to take that thinking and build it on the math content. And you all just have identified all of the different math content that a task like this could do. And we only did one problem. We only looked at one task, and this would totally be like an entire math class dedicated to. And now you could even throw out other questions like I did with Caesar. Okay, you found your fraction for your chosen region. Could you find another one and use a different strategy? Sometimes I throw it out there and I say, how many different strategies can you devise? Right? Especially that's for my higher level students. Yes, you went straight to your part over whole and you, okay, now can you give me 3 different strategies? I normally love doing that for my high level students, especially if I say you can't use the numbers, because now I'm forcing them to use the shapes, right? I'm expanding their thinking. I'm building on their critical thinking. What would happen if? I want students to ask, what would happen if I tried this? All right, let's move on to our next one. Here's another task. So I call this stop and think tasks. I love to do stop and think tasks, especially right before my students are about to take a test, right? Like I tutor as my second job, and most of my students that I tutor are in finals this month, and they're all freaking out. And every tutoring session is a stop and think task, because I'm like, if you're taking this test, the first thing you have to do is stop and think. Don't jump in and do things with numbers. So this is a task that I designed for my students to do. And sometimes I use it as a formative assessment. So I'm going to give everybody a moment to stop and think. Try and identify which ones, if the first one, second one, third one, and the fourth one are true or false. You don't have to type in the chat box. You can just do it for yourself. See if you can identify which ones are true and which ones are false. Oh, only using mental math. That's in my notes. That's the caveat. No pencil, no pen, no calculator. And I know that just made some of you clinch, but try it. Stop and think first. All right. Is there anyone who has an answer? Well, no, not the answer. Is there anybody who has a strategy that they're like, I just have to give my strategy for this one because I totally stopped and thought, Cynthia?
Okay, I guess I'll take a stab at this one.
Mhm,
So I'm looking at the first bullet and
mhm,
both of this is multiplication of decimals,
mhm.
and a negative times a negative is a positive.
So is that statement
That
true
would
or
be
false?
false.
There
That
you go.
statement would be false.
That statement is false. But
And
you
then,
would be shocked how many people I give this problem to, and they immediately set up the algorithm, or they immediately go, oh, multiplication of decimals. Ah! Stop and think. I agree with your reasoning. It is multiplication, and multiplying a negative times a negative gives you a positive result. So this answer has to be false. What about the second one?
so the second one is subtraction on one side, and 10,000 minus 99,999. When you subtract, it's going to be 1. So to the left, which is less than, 0 is not greater than 1.
Okay.
Because it's a positive 10,000.
Computation there for a second though, but I agree with your reasoning. Suzanne said identified the larger number and looked at the sign to determine that it was less than 0. What do you mean by that? If you want to type it or unmute yourself.
That's all that I did was I just said, okay, it's a positive 10,000, it's a negative 99,000. All right, so the answer must be in the negative realm. And then of course I identified the less than or greater than sign and made my determination that, okay, it's less than 0.
So what I'm hearing is that neither Tanya nor Suzanne needed to write like 10,000 and then 99999 and then draw the line underneath it and then do the minus sign to determine what the answer was, right?
Right.
Which one is the smaller number?
The 99,999 is actually the smaller number because it's a negative number.
Ooh, look at you.
Wait a minute. If you're talking about absolute quantity, then 99,999 is the larger bulk number before, but if you're talking about the number line, you're right. The quantity 99,999 is the larger quantity.
I'd agree with all of your reasoning. Thank you for attending to precision. But I would take either one of your answers, right? I would take if you recognize that 99,999 is in fact a negative number because that subtraction sign is indicating that it's a negative. But I would also take if you thought about 99,999 in its absolute value being a bigger number that you're taking away from a smaller number. Either one of those would work. But what I'm looking for is for students to be able to think and reason about what makes sense. Let's skip actually, let's not skip the third one. The third one is interesting because I see people really, really itch to do all of the math that their teacher told them to do, right? They really want to cross cancel. They really want to multiply across the numerator, across the denominator. But who actually stopped and thought about this one and resisted the urge to do all the things their teacher told them to do with multiplying fractions? No one resisted the urge? Oh, well, Kathy, you're muted, but I see your finger doing math.
I did, because I just looked at it as a positive and a negative number, and you're multiplying, so the result is going to be negative, which is not equal to 0.
There you go, right? It doesn't matter what those numbers are. If you're going to multiply a negative times a positive, well, it does matter. If none of the numbers are 0, none of the numbers are 0, and if one of them is negative and the other is positive, you can't possibly get 0 because a negative times a positive is going to give you a negative number. And the last one is actually my favorite, but we're going to run out of time and I want to make sure I give you all time to reflect. So this one, I actually will have to give us the critical thinking, and you can just thumbs up or nod and be like, yeah, I totally thought that. I saw that. I go after this one because I want to see, I normally use this task as a formative assessment, to be honest, because I want to see where students are already in their understanding of negative and positive numbers. But I specifically like this problem because I want to see where students are in their understanding of what the equal sign means. So I'm pausing to give you, maybe you want to rethink what you were thinking before. What does that equal sign mean? That equal sign means that the two things have to be equivalent. And I love to give a task called same but different. And that's all about helping people to understand equivalencies. Things that are equivalent are the same, but different, right? Like 1/3 is the same as 3/9 in value, but they're different because 3/9, the denominator is 9 pieces, and 1/3, the denominator is 3 pieces. So they're different, but they're the same, which makes them equivalent. So I want to know, do students understand equivalencies? So I'm looking for all kinds of things that people might say, but sometimes we get tripped up in rules that my teacher said, keep, change, change. When I start hearing keep, change, change, I'm like, okay, right? Like, what does that mean to you though? What does that mean to you? Remember, this is all about nurturing curiosity, breaking through the my teacher told me or I remembered. What do you think? Well, what I know is that, okay, that these things have to be the same on both sides. Okay, so where do you see that they are the same and where do you see that they're different? Well, these two things are the same. Okay. Are these two things the same? Are these two things the same? When you stop to think about that, you don't have to worry about keep, change, changing. You don't have to worry about PEMDAS, because all I want to know was this statement true or false? So what I'm modeling for us are tasks that do what? Promote critical thinking, because critical thinking is super important. What's not so important is whether or not my student has the ability to regurgitate every single step that I ever told them. What's more important is whether or not my student in front of me, if I've taught them how to think. If I taught them the confidence to say, hold on a second, let me figure this out. I love when a student says that to me. Hold on a second or wait, because that takes courage. That takes courage to say, give me the space to think for a second. Eric, I saw you on mute. Sound like
Yeah,
you
so
wanna.
my question was about the second one, right?
Mhm.
Where, like, you know, because Tanya was like, oh, it's one, right? And so is that like uh a function of like the 10, like the way it looks, right? Like the one and the bunch of zeros and then the nines, sort of
Yes,
like intuitively we're going to go to one, even though that's not the right answer, because
exactly.
we're thinking in whole, we tend to think in whole chunks, and we're like, oh, this is a whole chunk, this is a whole chunk, so it's
Mhm.
one, as opposed to like, oh, actually no, it's not. It's not one.
There's a
The-
lot of stop and thinking that happens here. So when that happens, that is when I ask students to say the number. ESOL people, there we go, right? Have you had lessons or practiced having students to say the numbers? Even native English speakers have trouble saying the name of this number. I hear the digits a lot. Oh, that's 99,999. That's not the name of that number. And when I want to help people understand what I mean by the name, I will literally say something like, your name is Eric. I didn't say your name was Erik. But saying 99,999 is like saying Erik. That's not your name. That's me saying the letters that make up your name. Saying 0.728 is like saying the letters or the digits that make up the name of that number. That's not that number's name. Let's practice saying its name. And if you say the name, now you'll hear it. So that's another critical thinking task, right? Like, there's a tip I give students. Allow your brain to hear your voice. Say the thing out loud. 99,999. When you say that, you hear that's bigger than 10,000. Right? And so now you don't make that like that connection that you were just talking about, right? We see the nines and you see the 10, right? Say the name. Try practicing having your students say the name. It's important for place value, but it's also important for us just to understand how big or small something really is. We take away its value when we say its digits, kind of like I take away the value of Astrid when I just say ASTRID. But when I said Astrid, I'm pretty sure she looked up, right? She heard her name. So we kind of lose the value of these numbers when we say 38.76. That's not the name. That is 38 and 7600s, right? Like when you take that pause and say, and now it means something to you, like 38 and 7600s. Any other thoughts about this task? This is a stop and think. This is an example of a stop and think task, but the overall task that I'm sharing with you all is called a stop and think. Coming up with things that force your students to what? Stop and think. Don't just jump in and do things with numbers. Or if you're a literacy person, don't just jump in and look for the answer in the text, right? Stop and think. Any thoughts about this?
Well, there's certainly, I've seen research at the college level that compares students in the US and Japan and China and other places, and some of the countries where like really sort of rote grinding it out does not pay off for this exact same reason, right? And so they start calculating and then they spend 15 minutes calculating and they're like, wait, this answer doesn't make any sense, right? And then, but in the US math education at its best, encouraging people to think critically before they start doing the calculations, it's you get the right answer and you get it in a quicker period of time, actually, instead of just immediately like trying to grind it out. I mean, the greatest example of this is, you know, word problems that are like, how many people do you need for this job? Right. And somebody would be like 3.75. And it's like there is no 0.75 of a person. So like you need 4 people for this job, right? So like really understanding what the problem is.
Exactly. And checking for reasonableness. That's another test taking tip that I'm sure we all give. That would be the first thing that I would say to that answer for the student, right? I'm like, did you check for reasonableness? But also that works here too. Stop and think. Did you check for reasonableness? Which is why I like to give stop and think tasks. So hopefully that's something that maybe you want to start considering doing more, especially if your goal is to nurture curiosity and critical thinking. Because the more that this is nurtured, the more efficient you actually become at math, right? The more efficient you become at math, right? When now that starts to become a habit, hold on, let me think about what makes sense. Hold on, oh, let me notice that these two things on this side are the same and they're going to cancel each other out. I did that recently with a student who was reviewing their equations, and they were solving the equation or something like that. And the answer was like 14x plus 36 is equal to 14x. And that was where she got at that point. There were other steps above that, but at this point, after distributing whatever, she got here. And I was just praying that we had done enough stop and think tasks for her to realize right here that they're not the same on both sides. So she doesn't need to minus 36 and what you do to one side, it's impossible for 14x and 36 to be the same as 14x. This is going to be no solution. And I waited and I was like, please do it, please do it. And she was about to start doing minus 36 and I heard her stop and think, and she goes, hold on. And I was like, yes, right? Stop and think. She did realize at that point, she's like, wait a minute. But she didn't remember it was called no solution, but she knew something was not right. Right? Okay. That's because we've taught her, she's learned how to think these things for herself and not get caught up in steps. So I got really happy about that. I was like, we don't need to solve this problem anymore. Don't worry about it. You figured it out. You're good. Okay. All right. So
but Cynthia, that muscle memory is hard to go against sometimes, right? That's equation. I got to do some subtraction and da-da-da-da-da. It's like, stop.
Exactly. You're like, no, I'm supposed to do things with one side and the other. And I skipped too far because I was trying to erase our buckets and Zoom won't let me be great. No. Stop sharing. I'm sorry. It won't let me erase the annotation that we just did.
If I could add something, I think that sometimes in math, we overcomplicate things. Like earlier, Eric was looking at the letters. He was like, oh my goodness, one is lighter than the other. What is this? Right? And then other times we'll say 3.7 people, right? So he's like, well, sometimes we see it, oh, it's so difficult when it's easy. And then sometimes when it's more complex, you just give a decimal representing people. Like, are you chopping people up? Like, put them in a room, right? So it's like you have to find that balance that, yes, it's not that serious, but math is real life also.
Exactly. And that's why I like critical thinking, because in real life, we all have to do it. We all have to figure things out. We all have to figure out how to get to work. We all have to figure out what to do if our kid's homesick. We all have to figure out what we're going to eat for lunch today, like that Liberty Mutual commercial, right? Where she's just like listing all the things you have to do when you're an adult. We all have to think. So let's take a moment to think. What thinking or understanding does a task like that engage? What thinking or understanding? It could be math related or habit of mind related. I really want you to just take a second to think about doing a stop and think task, whether it was that specific one or in general. What thinking or understanding would a task like that engage?
I think problem solving. Oh, sorry.
Go ahead.
Problem solving, right? Like a lot of those things maybe we've never seen before. But like you said, if we stop and think, okay, I can figure this out, I can solve this problem, you'll find the answer. If you go, well, I don't know, those parentheses next to the negative sign, what are they trying to ask me? But if you're just able to solve problems, even if you don't know where to start, you find ways. I think that's one thing we can use to engage the students.
Gotcha. Thank you for sharing that.
Well, and I think also to build on Cesar, I mean, the question is, what's the question? Like, what's the actual question, right? And so, and that holds for math and it holds for every other subject too. Like, what's the actual question at hand? Answer that rather than a bunch of distracting things.
Which I think Idel Rose, that's kind of what you said in the chat box too, asking questions. Because I know some of you might be thinking, well, one of the persons answered that a negative times a negative is a positive, but what if I have a student who doesn't know that, right? If I have a student who doesn't know that, but they ask me, what do these parentheses mean? I can work with that, right? Because that means they're still thinking about it. They're asking questions. For them to even ask, what do these parentheses mean, means that they've thought that those parentheses had value, were important, were relevant.
So
And
now,
that's what I
Cynthia,
want.
I want to ask you a question. So when my student tells me, I don't know where to start, I don't understand anything, this makes no sense, what can I do to guide them? Because I try to do things, but do you have a strategy you use that works?
Yes. And when I have a student who says that, I say the same thing every time. This works for everybody unless they're visually impaired. So that's my disclaimer. I always say, well, what do you see? And then that's when we do a notice and wonder. What do you see? Well, I see that there's a 30 on this side and there's a 30 on that side. Cool. That's why you saw I boxed them, right? Especially that last question. That gets a lot of students. And they're like, I don't know what to do. I don't remember what the steps in PINDAS. Nah. I'm like, cool. Take a deep breath. What do you see? And that's why I started out at the beginning talking about like we notice and we wonder. Unless you're visually impaired, that's my only barrier there. We can all make observations and notice things because then that takes us out of that place of I don't remember the steps. I don't know what you want me to do. I don't, right? Like, okay, what do you see?
Thank you. That's a great start, right? They'll see numbers, they'll see variables, they'll see something. So there's no more, oh, I don't get anything. Thank you.
Exactly. That's my favorite question. What do you see? Right? Tell me what you see. I see this, right? And I always, you notice how I circled it? I'm always going to do that because I want to validate their thinking. I'm going to validate your thinking. Oh, you see a dot there? Great. I see this dot too. Do you think that dot means something? Do you think it means something if I move that dot, right? So I'm always going to validate their thinking. Good question. We won't have time for this one. I inserted it just in case. I meant to do a what skip, but I'll show you this one. We're not going to do it, but this one, what makes this a critical thinking task? I want you to think about that for a second if you can, because I want to make sure we have time to reflect. This is another task. I actually made this one for some people that I teach online, and we were in our slope unit. So I'm going to pause there for you to think. The real question here is what makes this a critical thinking task, not the task itself. The question is, what makes this a critical thinking task? And if you're looking at it and going, Cynthia, that's math that I don't remember. Oh my goodness. I will just tell us what the critical thinking parts about it is, right? One, I've got to interpret the reading of this question, right? I've got to make sense of this. This is why a lot of people say, oh, the math test is just a reading test with numbers, right? Like I have to make sense of this, right? I have to maybe engage what I understand about negative slope. Maybe I now have to employ thinking about drawing it, right? That's critical thinking. Now I'm going into my toolbox, thinking about what can I do to try and make sense of this thing so that I can answer it. I have to make sense of what I know about lines and points that make up a line. Once I've made sense of all that, this is actually a really easy question to answer. Once I've made sense of, well, what does a negative slope look like? The line's going down. Okay, and now maybe I have to think about, okay, well, if I had my coordinate plane and I had a line that was going down, what would happen with these points? That's what makes this a critical thinking task. This is actually a high level cognitive task instead of me just saying, here are these points, graph them. But that's kind of what a lot of our math books and stuff look like. They're like, here are these points, graph them. Or we give them pictures of lines and say, identify if it's negative or it's positive. That doesn't require any critical thinking. But this task definitely requires critical thinking because now I have to employ what I know and or understand. Maybe I don't know what a negative slope looks like, but if I have a student who asks me, then I'm going to tell them because they thought enough that they needed to know that. Suzanne said mental picture of a graph, negative slope, and maybe this is another chance to reinforce students' understanding of what a negative slope looks like. So I like to pull up pictures of stairs. Everybody talks about stairs with slope, right? If you're going up the stairs, it looks like that. If you're going up the stairs, so that's a positive slope. But if you're going down the stairs, the line looks like that. It's a negative slope. Like once I pull that picture up, I love hearing the, oh, and then they go back and they're like, I can answer this question, right? I didn't have to do much except for give them a little bit of information. But for a student to recognize that they need that information, that's critical thinking. Any thoughts about this? Anybody critically thinking about critically thinking? Because I'm hoping that I'm stimulating your brain's buzzing a little bit. You're like,
Well, I'm questioning what I know about negative slopes because, or like why we consider a negative slope, because I was thinking like in my head, like from that 10-1, like whether I go this way or this way, I'm going down, right? And so why is this? Well, I have to, like, I don't, it's hard to tell because we're reversed, right? But like, so if I'm going down towards like the negative on the y-axis versus going down towards the positive on the y-axis, starting at 10-1, I'm going down either way, right? And so, right? And so then why is this one negative and this one positive? This one's only positive if you're starting some point that's not 10-1, right? So if you're starting 10-1 here, then it's positive. But if you're starting 10-1 here, they're both negative going down.
So now you can graph the line and you can try and plot them to see if your hypothesis or conjecture is true. But what I would say to a student thinking that is, what does it mean for 10-1 to be on the line? Because now I really want you to really think about that, right? What does it mean for 10-1 to be on that line? Okay, I know you're like, wait, but you didn't really answer my question, and that was on purpose. I'm like, I'm always gonna ask another question, right? What does it mean for 10-1 to be on that line? All right, so let's reflect. Oh wait, I'm trying to ignore the red box. Okay, here's a reflection question. Right? Because you just sat through a 45-minute presentation where we were just talking about critical thinking the whole time. And maybe you're like, okay, cool, I'm going to get my PD credits for that. But I really want you to think about, why is it even important to nurture a learner's critical thinking? Because at the end of the day, you might be thinking, my job is just to help them get their GED or to pass the Best Plus test.
To engage them. If they're not critical thinkers, it's going to be hard to engage them in the afternoons after they work. So if they're able to think, they can think critically, that means they're going to solve problems. They're going to try. They're going to be engaged.
Okay. I like it for engagement. Thank you. Michelle said, because math is more than just a test or an assignment. Michelle, you get one of these two. You too, Caesar. Both of you guys get one of these. There you go. That was like Nihal Kailan used to say, you made my heart feel super happy. Life skill, not just math skill, right? Engagement, lifing, adulting, more than just the test, to show them what they already know. I like that one too, right? Like a lot of our students have had bad experiences in the past, and there's such a place of deficit. But they have assets, they have strengths. Let's help them learn how to leverage and use those strengths. And critical thinking is going to be a good place for that, to encourage them to see themselves as competent and smart. I love that. Any other thinking or thoughts that you want to share? Even if you don't share it, I hope that you take a moment to reflect on this. Why do this? It makes our community more productive. They can teach and encourage others. I agree. That's kind of like in the same realm of Caesar, to improve problem solving. Yes. To make them better human beings all around, right? Because that's what makes us humans, that like we have the ability to think and process and problem solve. And, it's not the one that's the most sexiest answer, but I am our numeracy and workforce specialist. And so I have to throw that out there because it's a employability skill. It helps make me more employable. Employers want people who can critically think and problem solve and look at issues and say, what would happen if we tried this?
And, and more broadly, from a kind of a civic and social justice perspective, just because someone says something's equal doesn't mean it's equal. You can look at the numbers.
And that requires critical thinking.
That requires critical.
That requires critical thinking, right? Why that's the same but different. When is equality not the same as equal? Okay, so I hope this was helpful and giving you some things to think about critical thinking and nurturing critical thinking. Here is access to my slides, especially if you're like, well, I want that task. Cynthia, that rectangle one was cool. I'm going to use that tomorrow. This is if you scan the QR code, it will take you to the presentation of the slides. I would encourage you to bookmark it or add it to your Google Drive or make a copy of it, however you want to make sure that you can access it again. If Eric sends me an email to remind me to do it, I will send you the link in case you're sending it out for all conference goers.
Yep.
But this is the QR code to access the slides